Welcome to this first experimental live coding session. What I have in mind for today is to continue working on my DOS demo project, which I have been working for some time, but unfortunately I didn't give it the attention it needs this past few months, and I have in mind the possibility of possibly finishing it for assembly, the demo party which is gonna happen this year at October. So maybe if I finish enough effects and cobble them together to form a demo, maybe I'll have something for the compo. So I don't know, this may be boring, but I'm just gonna be coding, so I'm not gonna be explaining very many things. Maybe I will be thinking loudly or not. We'll see how this goes. In any case, thank you for joining me. So, where was that demo? Demo scene, DOS demo, yeah, that's here. So I have this demo project and I can't even remember, wait a moment. Let me make sure that the stream is working. Is it live? Yeah, it's live actually. All right. So anyway, where was I? Oh yeah. So I have this project here that I started years and years ago. Actually, the first commit on this was back in 2016. In 2016. But every year it got pushed back and pushed back, so maybe I'll manage to finish it this year. I don't know. We'll see how it goes. So the setup here is that I have what do I have here? I have these multiple make files. So I have, for instance, the GNU make file, which is for the Linux version of the demo, which basically includes pretty much all the code except for DOS specific things, and it's helpful to be able to, I don't know, debug easier and have a shorter edit, compile, run loop, let's say. So mostly I'm gonna be working on the Linux version basically, but the point of this project is that it will run on DOS, and it will work on a Pentium 1 at 133 megahertz. Then I have where is it? Then I have this make file, which is basically a make file for Wacom, and this is supposed to create DOS executables either from DOS directly, which I'm going to be testing from time to time to make sure that I don't write anything that doesn't actually work on DOS. And also it allows me to cross-compile for DOS, which is also very handy. So yeah, let's go. Let's see what state I have left this in. Yeah, that's my loading bar. Oh yeah, right. So this was the last effect I started to work on. It's not finished yet. Yeah, I'm not quite sure what I'm gonna do with this. Maybe this is what I'm gonna be working on today, I think. And then I have a bunch of other effects. The first one is a tunnel effect, which is, I mean, it's pretty much, let's say, done. But maybe At some point I will want to add some foreground sprites on top to make it a bit more interesting, maybe a title page or something. We'll see about that. Then I have a fractal which actually runs very slowly on the target machine, so this will probably not be part of the demo, or if it is, I really need to make it much faster than this. This is an effect my friend Samurai was working on, and it's very nice. It's actually an let's say I won't say it was stolen from another demo, but let's say it's very similar to an old DOS demo called Robotnik, a scene from Robotnik. It's not finished yet, and I hope Samurai intends to finish it, but it looks really nice. Then this is a test for the 3D code I've written for the demo. This one is a very simple plasma Optimus was working on the last time, but I think it was a test effect. It's not going to be part of the demo. This was a real effect Optimus was working on for the demo, but he never finished it. I don't know if he will. This was another effect by Samurai, obviously also not finished, but it's I mean, it's nice. It can go places. Oh, that doesn't even work correctly. Alright, so that was a Metabolts effect which needs a lot of optimization. I was working on that. Needs a lot of optimizations before it can run properly on a Pentium 1. This also doesn't work. Actually, I made some changes recently to my 3D code because I was working on a DOS game, and I backported all the changes from that, so that's why many parts are not even working correctly at the moment. This one's working. That's fine. That's another effect I was working on. And did I have any more? I think I had a console somehow. Yeah, that's right. So I had a console with commands. So ls would tell me the demo parts that I have. Alright. Oh yeah, okay. So basically we're at InfCubes, and then there is Hairball, which doesn't really work correctly. Yeah, that sucks. That's not even an effect at this point. And then what was the other one? Oh yeah, and Cybersun, which is the effect I was planning to work on today. So let's forget about all the broken effects and try to make this into something nice. Right, so what do I want to do with this? I think the idea behind this is to start with typical, I don't know how to call it, cyberpunk, cyberspace grid or something, which is flat initially, and I think then I want to have some sort of a mountain range at the back and the sun raising. I mean, not a realistic sun, just something like an 80s nostalgia purple sun or something. I don't know if you understand what I'm talking about. And then, I don't know, maybe the sun explodes and the grid starts rippling like what I'm doing right now. Oh, this looks really bad. Right, so I think the first thing I want to do with this is to make it start flat, and then at some arbitrary point in time start rippling. And maybe not like this. Maybe it should do a circular sort of ripple, like emanating from the center and going outwards, and then maybe distort to something like a wormhole. I don't know. Okay, this is really crappy. Let's see the state the code is in. Right, so I think all the effects are in the directory srcscr. So srcscr, what do we have here? Cybersun, that's right, that's the one. Cybersun.c. Alright. Alright, okay. So actually I had been working on this pretty recently, because this was after the backport of all the changes from the game code. And that's why this one works, while most of the other effects are broken. Anyway, I have to remind myself how this demo system works. I've written this, well, I wouldn't call it an elaborate framework, but I've written some sort of structured way to add effects to the demo. And it all revolves around this screen structure with the name of the effect, and then a couple of function pointers for initialization, distraction. Yeah, then I have a start function, which is when this part of the demo starts executing. And this null pointer here is for a stop function, if I need something to happen when I switch away from this part. And then obviously a draw function that gets called all the time to redraw the effect. So in order to do anything that changes over the course of the effect, obviously I have to have some sort of timer that starts counting from when the start function is called, and then I will have the time relative to the start of the effect, so I can do stuff with it. All right, let's introduce a new global here. Static. I think my times are integers. Are they integers? Yeah, long trans time. Trans time, what? Oh, time msec. Okay, so I have a global time msec variable, global the whole demo, that counts from the beginning of the demo. So I need something like a part. Actually, no. I need a long part start variable. Okay, that gets initialized in the start function. So part start equals to time msec, and that way I can keep track of when this part started executing. So now let's make something simple first. Let's make the amplitude of the rippling be a function of the time from the start of this part. So instead of using time msec here, I'll base this t variable to well, actually, time msec minus part start. So I have the part relative time, and then I'm dividing by 1000 because this time is in milliseconds, and it's much easier to work with seconds for. Well, we'll see about that. And where is the amplitude? Okay, so I have a bunch of sines and cosines, which actually these will need to be optimized at some point and turned into lookup tables. But for now, while I'm working on this and figuring things out, I'm gonna keep it flexible like this. So, what, the z variable, the z coordinate? Is that right? Oh, maybe the plane is actually generated on the xy plane, and then I'm turning it 90 degrees. Yeah, that's right. I'm turning it 90 degrees so that it faces upwards. All right. So, what do we have here? All right. So it's very easy actually. So I have to do vptrz multiplied. Well, I can't multiply it by the time directly because that will increase forever. But okay, multiplied it with amplitude variable, and this amplitude variable is going to be t. Well, actually, if t is less than, I think I have a convenient smooth step function somewhere. I think it's in libs cg, yeah, that's right, libs cgmath cgmath.h. This is my math library, and I think I have a smooth, yep, I have a smooth step function. This is very convenient for this, this sort of thing. So the amplitude is the output of CGM smooth step, and then we have the let's define 2 points in time. We have the time when we start transitioning from a flat plane to a rippling grid. So let's call that TM ripple start, and and we need to end the transition when we reach the highest possible magnitude. So let's call that TM ripple start plus TM ripple, how should we call this? TM ripple transition len, whatever. And then the last argument is obviously t. Okay, so then we're just multiply by that amplitude value, and now we just need to define these two times in relation to the start of the part, not the demo itself. So define TM ripple start. Let's let's call it, for ease of debugging at this point, let's call it 1 second after the start of the part, and then define TM ripple translen. Let's make that, I don't know, 3 seconds. 3 seconds. So if we try that, do you have a warning? An error? What's that? Implicit declaration of function smooth step, right? So obviously I have to include this math library here. Include cgmath.h. Let's try this. What was that? Demo. Oh, and I have to make this loading a bit faster. So we start flat and then we start rippling. All right. That's obviously crap at this point, but it's a first step. Okay, so maybe I want all the times for this part to be on the top, so I can tweak stuff later. All right. Let's get rid of this. So that's it. We're done. That's the effect. What am I gonna do with this? It looks really ugly. I think I also need a better texture. I need a texture that doesn't saturate to purple, but goes to white in the middle, so it looks a bit like I don't know, an oversaturation of light. And obviously the effect is crap at this point. I probably don't need a ripple for this. I probably need some other kind of distortion to happen. But in any case, oh, do I also have spaceball controls for this? I think I do. Let me try something real quick. Come on, yeah. Is that it? Nope, wrong USB plug. Where the fuck is this? me move some stuff out of the way and try it again. So, oh come on, let's make this go faster. Where was that? Come on, src. Was it in main? Was it in demo.c? Was it in loading? It was in loading, I guess. I bet it was in loading. So by the way, the reason that when I started the demo it directly went to the effect I'm working on is that I have a configuration file, which is really handy. So I have this demo.cfg, which basically tells the demo system that I've written to start from the screen called CyberSun. So basically, when I create a new screen, I'm registering the new screen in a list of screens. Let's say each one has its own name, as you saw in the console I used previously, and I can specify which one starts when the demo begins, which is really handy for working on a single effect without having to switch all the time between effects to find the one I'm interested in. Alright, so here I have sball equals false. Let's change that to sball equals true. And let's... Wait, what was I doing? Oh yeah, the loading thing. Alright, so src... I don't remember anything about this. Screen? What's the screen? Wait, I know. Get come on, get env. A bunch of get envs. There it is, mlabs load delay. Because in the final demo, because I really liked that progress bar. Yeah, it is an actual progress bar. It gets incremented every time a new part is done loading its own resources. But I really like that progress bar, and I want it to be visible in the final demo. So I have an artificial delay if the loading of each part lasts less than a few milliseconds. I artificially extend it so that you can see and admire the loading bar. But during development, obviously, that's not something you want to do. So that's why I have this export. I have this environment variable that I can export. mload delay equals 0. So now it should start much faster. Yep, that's nice. And does the... Yeah, oh shit, what's going on? I'm moving the space ball, but something is really screwy here. Oh. Do I have the directions wrong? What's going on? Come on, what's going on? So wait, when I turn that way, oh, right. So the motion is object based. So I'm actually moving the grid, not the camera. That's why it's confusing me, and it's also too fast. Oh come on, it's way too fast. You know what? Fuck it. I don't care. So let's start with the sun. I need some inspiration for this, so I'm gonna look around on the Google Images page to see what can I do about a rising sun for this effect. How is that called? Wait, I have another tab here. So what is this thing called? Retro something? Retro wave? No. It's called something else, I can't remember. Let's start with retro wave. Sun. Let me bring that tab here. Okay, so obviously there was a problem with the stream. It cut out, but I don't know why. I restarted it and it looks fine. We'll see how it goes. Okay. So, as I was saying, I don't know if all this went out to the stream or not, but as I was saying, this is the sort of effect I'd like to do, not the one with these lines, but some sort of solid sun, maybe like this one, and potentially, and obviously I also need something like these ridge lines, something like these mountains on the horizon. The best thing I can probably do and the sun needs to be behind the mountains. So the sun needs to be obscured by the mountains. I'm thinking because it's actually, I mean, obviously this was going to be extremely easy to do in a modern system where you have infinite, essentially, processing power and in the GPU. But I need to think of a way to implement this such that the performance is going to be sufficient on a Pentium 1. So that's something to consider. Obviously, if I was going to do this in a modern machine, it would be extremely easy to have, I don't know, something like, even if I wanted to make the mountains two-dimensional images, it would be extremely easy to have a cylinder around the scene with an alpha blended mountain range mapped onto it, and then have the sun, I don't know, rise behind it or something. And then the sun would be alpha blended itself, so that I could have a background layer which would be something like a gradient or something. And obviously on a modern system all this would be even easier to do on a shader. The problem is that alpha blending is expensive on retro computers, computationally expensive. And okay, so obviously if I'm gonna have this perform well on a Pentium 1, I should not use alpha blending for the mountains, but some sort of alpha testing. So basically I should have something like a color key and some custom code that overlays the mountains. So instead of using polygons and my 3D rendering code to do this, it should be better, I think, to write some custom code that takes the angle of the view. I don't know. This is too much to bother. Takes the angle of the view and then maps an image while also doing color keying. I don't know. Another idea would be to have the mountains on the background, so maybe some sort of a cube map. Because I've done this before, actually, let me show you. So I had this game project a couple of months back, for DOS again, for pretty much the same target, although it ended up needing a Pentium 3 to run properly. But nevertheless, where is it? Code, game dev, eradicate. So I had this game project. Let me mute it first. Game.cfg. I have a similar game.cfg file. Oh, music equals 0. Is that muted? I think that's muted. All right. So this game. Come on, let me start. Okay. So this game uses the same 3D rendering code that I have in the demo, and has this nice cube map for the background layer. So as you turn around the track, you can see different parts of this background. and it was actually implemented pretty much straightforward, as straightforward as you can make it, and it wasn't that much of a performance hog on the target computer. I think this would be okay to do, but also it's a bit wasteful for what I want to do in this demo, because I only need the gradient. I don't actually, for the background, I don't need full three-dimensional environment around my grid. So that's a bit wasteful, performance-wise. And also, it can look better if I can, I don't know. Okay, so if I was to do something special case for this mountain range, what would that be? What would that be? I can extract the angle of the camera, the horizontal angle, let's say, and use it. I mean, it's all, yeah, I can extract an orthonormal basis from the camera matrix. I mean, even not have to do that. Do I have to do that? Maybe I'll already have the camera angles. Let me check. What do I have here? Okay, so yeah, obviously, right. Okay, so right now I have this mouse orbit update thing, which is obviously for debugging. It's not going to be there on the final demo because the demo is not interactive. I have this just to be able to look around, but it would be nice to actually have the effect work correctly when I look around with the mouse, as well as with the pre-recorded, let's say, and it gives me a bit of flexibility that way, because I can pre-record the camera motion, a completely free camera motion, and have that playback as the demo runs. Yeah, so ideally, and I do have the angles I need here, don't I? Yeah, I have cam theta. So basically this function reads input from the mouse and updates these three variables, which are the horizontal angle of the camera, which I'm calling cam theta, the vertical angle of the camera, cam phi, and the distance from the center. So basically, yeah, the distance from where the camera is pointing, let's say. So if you make this distance thing 0, you basically have a first-person camera, and if you make it larger than 0, then you have an orbit camera. So basically, the camera turns around the point of interest. So let me actually try this. I think I can make this work. So if this is, yeah, actually, right now the camera distance is 0, so it's more like a first-person camera. And if I think I can use the right mouse button to increase that. Yes. So if I drag with the right mouse button, that now becomes more of an orbit camera. So I'm focusing on a central point and moving around it. Yeah. So anyway, the point is that I have the angles of the camera. So maybe I can just use the cam theta value as the horizontal coordinate for the texture, for the image mapping. And if I only use that value, then it's going to be fixed on the horizon. It's not going to move up and down as the camera moves up and down, which is not what we need. Spherical coordinates, basically. Yeah, no, it works though, because if I can also use the cam phi value as the vertical texture coordinate, and then wait, what am I talking about? Not the vertical. I mean that point. That, yeah. Okay. So that defines the center of projection. That's a single point in spherical coordinates. So I also need the field of view, which can be approximate. It doesn't have to be accurate. I also need the field of view of the camera to figure out the range of pixels that need to be drawn horizontally and vertically. You know, I'm just gonna experiment with this, see how it works. So I'm first gonna need an image for the mountain range. So let me make something really fast. GIMP. Well, not like this. GIMP. Okay, this is gonna be city. File new. Let's say. Okay, how big should I make this? Right, so the resolution of the demo is actually 320 by 240. And let's say that its screen full is about, it's less than 90 degrees. Basically, screen full is about, I don't know, 50, 60 degrees of field of view. So, in order to encompass the whole hemisphere, the whole circle around the scene, ideally you would have, if it was a unique section of image for its direction, maybe something like 4 times that resolution would be appropriate. So yeah, 1000 and something. But I'm not going to do that. I think I'm going to repeat the texture horizontally. I just want to make sure that you don't see much repetition in a single screen full. So I'll start with something like 256, I think. Or is that too low? Maybe that's too low. Maybe something like 512 by 128. Something like that. That makes sense, I think. We'll see how it goes. Okay, so I want the background. I'm sorry. So I want the background color to be black. No, actually I don't. I want the foreground color to be black, and I want the background color to be a unique color that I'm going to be using for color keying. So basically something like ultra saturated green or purple. In this case I think I'm going to choose green. So 100% green is my background. Where is the bucket fill? Where the fuck is the bucket fill? Oh, here it is. Alright, so that's the background. And now I'm going to paint mountain range. And I definitely don't need any feathering. I want crisp pixels because I'm not going to do any alpha blending. It's going to be visible or not visible. No in between stuff. Alright, so something like, I don't know, oh shit, this is bad. This is horrible. Okay, so that's my mountain range. And come on. Oh, Jesus fucking Christ. Where is it? Yeah, okay. Beautiful. That's a piece of art. That's brilliant. Okay, so I'm not gonna. And also, that's not good because it actually has a bit of feathering. I don't need that. I can fix that though. I can fix that later. So let me first make it slightly better than this. Maybe. Shit. Does this even work? Oh, come on, this is horrible. Okay, so let's take the paintbrush again and maybe paint some green. Oh yeah, that's better. This is horrible. Okay, so that's more like a map. No, the valley is crap. Holy shit, what am I doing here? Okay, this is really bad. This is really bad. Okay, I think I need a smaller brush. I wish I had an artist to do all these things. I don't. I have to do all the art for this project, I guess. Which is really bad. because I have absolutely no artistic talent. I mean, this is obviously a test, I can replace that later. This is, yeah. Still though, if I can make it slightly nicer, it's gonna be nicer. I think I'm making it worse every brush stroke. Holy shit, this is bad. Oh, come on, what am I doing? Swap the colors again. This is funny. Ugh. Yeah, let's make it a bit less distinctive, because then you're gonna be able to identify that peak when the repetition happens. So let's make them all about the same size, and then I'm gonna add secondary peaks. So something like this, and this, and this, like some. Oh shit, that's bad. Something like this, and then a bit here, and a bit here. This is horrible. This is a bad idea. I shouldn't be doing this. Oh, come on. Alright, let's call it a day. Okay, this is bad. Okay. Now the trick. Where the fuck is that? The trick is the following. I need to layer. Yes, transform and offset. So I need to offset this horizontally by 2, and now it's gonna be very apparent where the discontinuity happens, and I can fix that, or I can try to fix that. I think I'm gonna take it slightly lower here, so maybe it becomes like this, and then raise it slightly. So the point is that if I can make these two parts of the image work together nicely, for lack of a better word. This looks really artificial here. Okay, something like that. Alright, so now if I return to the previous offset, which actually can do with repeat offset, it's still fine. So that's going to wrap around nicely. Okay, so the idea now, obviously the next thing I have to do is get rid of this these intermediate values, because I actually need this to be binary. I need black and green, nothing in between. So I think I can use something like, what was that called? Not curves. What was that called? Threshold, I think threshold. Where's yeah, here it is, threshold. Ooh, nice. Alright. Well, obviously this is white, but I'm gonna fix that easily. So yeah, threshold allows me to pick a value in between all these colors and use that as a hard barrier. That would make sense? I think it makes sense. So now I can make that green again, and this is exactly what I need. It looks ugly though. Maybe I'm going to change it later. Maybe I'm going to use alpha blending after that. We'll see how that looks. So now I need to save that. Export as. Okay, so where is it? Code. Demo scene, I think. Where is the director? Demo scene. DOS demo, data, mount. No, wait. This is a DOS demo, so I need to keep the file names 8 characters long plus 3 character suffix. So let's call it mount cyber mount because it's going to be used for the cyberspace effect. Is that 8 characters? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8 characters, right? Yeah. All right. So export that as a PNG. And actually, I want this to be 60 bits per character. Can I do that? Oh, that's bytes. Okay. So let's call it 8 bits per character RGB. And I think my importer is going to convert it automatically. Export, if I remember it correctly. So let's quit. Display data side mount. That's right. Actually, this is a pretty big image. Probably I can get away with a much lower resolution than this. Okay. So I need to load this during initialization. Yes, see, I have a load image function. So if load image, let's call it mount text, whatever, mounted means whatever, I don't care. Data sib mount with PNG, then -1, and I need to add another image. So static struct image mount text, and then obviously I need to clean that up when I'm done with it. So destroy image mount text. That works. And now for the hard part. I need to actually show that. Okay. Okay. How am I going to do that? So I need a function. Right, so I need a function that takes as an argument, well, not even as an argument, I mean these things are global, the cam theta and cam phi variables are global. So uses the cam theta value to calculate the starting pixel of the frame buffer alright, so the starting angle, the angle of the first pixel of the frame buffer and the angle of the last pixel of the frame buffer, and then it's going to use that range to map into the texture. And I also need to do something for the vertical direction, but I'm not going to bother with that yet. So let's start by defining a function draw mountains. It doesn't need anything at all. Then in my draw function, at some point I'm clearing the background. That's right here. Maybe at some point later I will be able to avoid clearing it at all. But for now, I'll just call the draw mountains function right here. And then I need to actually implement that function. Okay, so all right. Do I actually need angles, or I can just fudge it with some arbitrary values there? So I have cam theta. Cam theta is a floating point number, and it's in degrees, I think. Cam theta is in degrees, I think. Okay. So let's say that the horizontal range, let's not call it that. I don't know, wait. So let's say okay, obviously I need a loop that does whatever needs to be done for every column of the screen. So that's 320. Do I have that defined somewhere? Not that it's ever going to change, but I think I have it somewhere. That's right, FP width. Alright, so FP width, that's the width of the frame buffer. So for now what I'm going to do is just, this is going to look extremely silly, but it doesn't matter. What I'm going to do for now is just have a band at the top of the screen, like a narrow band, showing the mountain range. So we need the coordinate from where to start, and we need the coordinate at the center. So let's have an x coordinate, and let's say that x equals to cam theta minus, actually, you know what, it doesn't matter where cam theta points. I mean, it could be the center of the screen or it could be the left side of it. It really doesn't matter at all. The only thing that this is going to affect is a slight offset of the mountain range. So let's say that I'm converting cam theta. Cam theta though is in degrees, so that goes from 0 to, and maybe it even goes beyond, because I'm passing that to trigonometric functions. So maybe cam theta can be unbounded. What I want to do now is divide cam theta. Right, so divide cam theta by use the module. Wait, alright, so I have this. So first of all, cam theta, I want to convert it to an integer, because I don't want to do this with floating point math. There is absolutely no reason to do this with floating point math. And I have a convenient function for converting this to an integer, because if you're going to do something like int cam theta, this is absolutely fine for a modern machine. On a Pentium, this is extremely slow, for reasons which I'm not going to get into right now. But this is really slow. So I have a special function for this sort of thing, and I don't remember in which file I have it. I think it's in util.h. Yes, this is the one. Alright, so I have this function which does magic, and these are the, I mean, if you want to look up more details of why this is necessary and what this does, there is these very nice references right here. So basically it does some magic with the IEEE floating point representation to convert a floating point value, and actually a 64-bit floating point value in this case, to an integer, obviously chopping off any decimal precision you have after the decimal point, but converts it to an integer as fast as possible. Basically as fast as possible means without involving a conversion instruction of the x87 FPU. Alright, so in order to do this, I have to call caround64 cam theta, but this is a value from 0 to, I don't know, 360 degrees. So before I convert it, I want to multiply it by some arbitrary value. Maybe, I don't know. You know what? I don't care. Maybe something like times 2. Make it something a little bit more reasonable precision-wise. So when I convert it to to an integer, then I can go on and divide. Wait, what am I talking about? No, I can go on and use a modulo operation, which is also pretty bad. Actually, I can do this better. Instead of multiplying by 2, right, so we have this value which ideally is between 0 and 360. I can multiply it, so I can divide by 360 and multiply, and actually I can do this in one operation. So I can multiply by 256, obviously we're still in floating point numbers at this point, divided by 360. So this gives me a value from 0 to 256. This is nice because then instead of using a modulo operation to actually get a value from 0 to 56, because this is going to be a value that when the angle is 0, I will have a value of 0, and when the angle is 360 degrees, I'm going to get a 255. Am I going to get 255 or maybe 256? In any case, yeah, but the actual cam theta value might be, I don't know, it might be 3000 or something. It doesn't matter because I'm actually using that as a camera input, which means basically that it gets fed into a cosine somewhere. So that's periodic. It doesn't matter what the value is. Right, but I do want to convert it to a value from 0 to 256 in this case. So the naive thing to do would be to, if I didn't have this division here, and I had it like this, right? So the naive thing to do would be to, I don't know, get whatever, multiplied by 2 as I said initially, and then take the modulo of that by, what is it, 6, 700, whatever, 2 times 360, alright? The problem with that is that a modulo operation is performed by doing a division. So this is the remainder of the division, and you have to use the divide instruction, which then gives you the actual, I mean, the actual result of the division and the remainder. And this modulo operation just keeps the remainder and uses it. The problem with that is that divide instructions are really slow. But if I can make this be a power of 2 like this, so now the usable range of cam theta that I need is from 0 to 56, then I can just perform a masking operation, so I can end with FF, and that just gives me, so if the value of that goes beyond 256, it wraps around to 0, basically. So that's what it does. And that's what the modulo would do as well. It would be modulo 256 in this case. But this way I can use an end operation which is instantaneous, basically. It's just one cycle. Right. So that's what happens. Alright, so now I have the starting x position, and the idea is to go through this loop and every time through the loop increment that x, which is an arbitrary thing to do, but it doesn't matter. I think it works fine. So yeah, and then draw a column from that image. This is potentially inefficient. The ideal thing to do when bleeding images on screen is to go horizontal. I mean to have the outer loop be the vertical loop, so you can output scan lines at a time. Do I care at this point? Does it make any difference? Is it easily refactorable to the other thing? I can worry about that later. So let's say that inside this I'll have a J loop, which is going to be as tall as the image itself. How tall is the image? Oh yeah, it's a struct image, so I need to look that up. I can't remember. src image.h. Okay, so I have a width and a height here. All right. So basically, j less than mountain text dot height, j plus plus, and then, all right. So I need a pointer to the frame buffer. That's the first thing I have to do. Uint 16 stuff. 16t. That's the pixels in the frame buffer are 16-bit values because I'm using a 16-bit color space for the demo. So pptr equals fb pixels, and what I want to do with this. All right. So for each column of the image, should I have a pointer to the source image? Yeah, I think I should also have uint 16t. Let's call it SP. Okay, so let's call this dptr, like the destination pointer, and let's call this the source pointer. So that's mount text. Oh, come on. Mount text dot pixels. And then what I'm going to do is sorry, that was a brain fart for a second there. What was I talking about? Oh yeah, sure. Okay, so I'm copying to dptr j times the FB width. Okay. Okay. J times the FB width. Is that right? That's right. Okay, so I'm copying there the value I get from SPTR J times. You know what? Since I know. Okay, well, never mind. Okay, so J times mount text dot width. This is slightly inefficient. I'm gonna fix this up later. Let's just have this. Let's just test to see if this thing works. Okay, so I'm copying from SPTR J times mount text width to dptr J times FB width. I think that's right. Looks right. Looks right to me. Alright, so basically what I'm doing is copying the this inner loop copies a full column of the source image to the frame buffer. And then I'm going to advance the pointers. So dptr++, SPTR++. So we're pointing to the next column in both cases. Oh, but that's not as simple as that. The dptr can be just incremented like this, but SPTR will wrap around at some point. Actually, it will. Yeah, it will. Oh, and another thing, SPTR should not start from mount text pixels. Yeah. Okay. So that's one thing. Let me refactor this slightly. Unit 16p dptr SPTR. So let's have all the definitions up there, declarations up there, and then I can put that X calculation before those pointer initializations. And then what I need to do is SPTR be mount text pixels plus, well, I guess X. That's a value from 0 to 256 though. Is that right? Is that what I'm gonna do? No. No, that's not right. Wait a second. So ideally, we need this starting position to. No, that's fine. Is that fine? I don't know. Is that fine? I need the starting position to change based on where the camera points, right? So I can do something like mount text pixels plus X, but that doesn't help me at this point because the image is potentially, and in this case it is actually larger than the screen. So it's well, it doesn't matter if it's larger than the screen. It's larger than the 256 range of that X value. Actually, I should just make that range larger. Should I just make that range larger? Do I have a leeway to make that range larger? Let me actually see if the camera calculation clamps that value or not, because I'm going under the assumption that it doesn't, but it might be the case that it actually does. Where was that? src demo.c, I bet. So orbit Mars orbit update. What are we doing here? So if there you go, the theta value, yeah, it doesn't clamp it. Okay, it doesn't actually clamp it. So this can grow, and actually it can become negative. This can grow and it also can become negative, which I haven't considered. Obviously I should have. Okay. Alright, so in order to account for this becoming negative, that's quite easy. The only thing that needs to change is that after constraining the range to, well, after mapping it to a reasonable range, like 256 as I have here, I then need to add 256. What am I talking about? No, wait. So after the masking operation, no, it doesn't make any sense. Okay, so we can have negative values. I can use fmod to constrain it to a range of minus, I don't know, minus 360 to 360 while it is floating point, and then add 360 to that, so that we're guaranteed to be to have a positive number. I don't want to do that though. I don't want to use fmod for this. Probably doesn't even matter. I think I'm just overcomplicating things just because I'm thinking of what the performance is going to be at the end. But at this point, it probably doesn't matter. I can just do the simple thing and optimize it later. But is there an equally simple way to achieve that without doing floating point operations? So if I do the mapping, this can be a negative value. And then, well, the thing here is that the end operation with 0xFF is going to chop all the high bits, so it basically is not really equivalent to a modulo, because it's going to forcefully turn it into a positive number, but it's going to introduce discontinuities around 0. That's not what we need. Okay, so let's do the easy thing first, and I can optimize later. So before converting it to integers, before converting it to an integer value, I'm going to use fmod. And do I want to do that before or after the range conversion? Does it matter? I don't think it matters. Alright, so I can use the modulo operation to constrain that to basically between minus 256 and 256. Alright? So after I do that, I can add 256 to that. So potentially the range of the result is 0 to 512. And then when I convert that to an integer, I can mask it to make a repeatable value from 0 to 256. However, is that a range that makes sense for this usage? Because if I'm gonna add X to SPTR so that I can start from somewhere further down the image, I want that X to be larger than the image. And maybe my image is slightly too large at this point, and maybe I could just resize it and make it so that 256 is a sufficient value for this. Do I want to do that? You know what? Maybe I do. Otherwise, I can obviously increase the range of the converted cam theta value. Instead of having it from 0 to 56, I can make it from 0 to 512. It doesn't matter. It can be any range at all. So yeah, in this case, I'm going to use a larger range. So something like 512. So this becomes 512 and this becomes 512. And then the mask becomes 1FF. Is that right? Sure, it's right. Of course it's right. Okay. You know what? I need to convince myself, but it's obviously right. Python. Yeah, that's 5. Yeah, okay, that's 511. The next one is 512. Plus 1. Whatever. Alright. So in this case, then I can just use this X offset to start from further down the image. The tricky bit though, alright, that's not tricky, that's very easy. Alright, so before incrementing SPTR, what I'm gonna do is actually increment X. So if ++x is larger than mountText.width, larger or equal to mountText.width, in that case I want to wrap X around back to 0, and I want to make SPTR point to the start of the image. So SPTR is in mountText pixels. Otherwise, I want to do SPTR++. And there might be a slightly more elegant way to do this, but I don't want to bother. Okay. Now then, so we copy pixels from the source to the frame buffer, increment the frame buffer pointer. That's fine because it's going to be from 0 to frame buffer width, -1. And we also increment the source pointer as long as it's within the bounds of the image. Otherwise, we wrap it around to the start of the image and continue from there. Alright, let's try this. Did I forget something? Obviously I did. Implicit declared, yeah, okay. So, shit, what did I do? Undo. Alright. So, include util.h. I'm going to do this in the opposite order. Make demo. What the fuck did we do? Oh, nice. It sort of works. It's, yeah. It's kind of bad, but it sort of does what I had in mind. Okay, obviously there are many problems with this version. The first obvious problem is that it doesn't sync up to the rotation of the rest of the scene. This is because I just use an arbitrary range instead of mapping the angles correctly to the field of view of the camera. And now I realize that it's probably a good idea to do that. You can think of it as as a weird parallax effect, but it doesn't really work for a parallax because you don't see parallax when rotating. You just see parallax when moving around. Anyway, it doesn't matter. So that's the first thing that needs to be fixed. The second thing that needs to be fixed is that I'm totally ignoring the up and down motion of the camera at this point. And the third thing, obviously, is that I'm just drawing this at the top of the screen, which is easily remedied. Okay, actually, it doesn't look half bad. I mean, as far as silhouette of mountains goes, this is pretty okay, I think. And you don't really see the repetition that much. I mean, you can't tell that it's repeating multiple times. Nice. Okay, so how do we take the vertical rotation into account now? Obviously, or should I actually fix the angle? I think I should fix the angle first, because I will need to do something similar to that when I take into account the vertical rotation. I need to obviously take into account the horizontal field of view while rotating horizontally, and the vertical field of view when rotating vertically. So my mapping is not going to be as simple as this. It has to take angles into account. And how do I do that? Okay, so if you see here, when the part starts, the perspective matrix is defined with a field of view of 50 degrees. That is the vertical field of view. So basically the horizontal field of view is that times the aspect ratio of the screen. So that times 1.33333 periodic. Alright. So if we have the horizontal field of view, which we do, we can use interpolation to figure out. You don't even need interpolation, we actually need a step value. Right now what I'm doing is stepping a single pixel. No, that's not the issue. Wait. Where does this fall apart? The problem is in the conversion of the x value. This doesn't matter. The single pixel step is fine, because that will only affect the aspect ratio of the mountains, and we can change that. It doesn't matter at all. The only thing that needs to be fixed is this x calculation here. So instead of just arbitrarily mapping, what am I mapping here? Instead of arbitrarily mapping 512 pixels of the source image what am I doing? 512 pixels of the source image to 360 degrees of rotation. Is that what I'm doing? Wait, is that really what I'm doing? Wait. I can make a debug image that makes this easier to see. So let's fire up GIMP again. GIMP. So file, open recent, SIB-mount, whatever. And you know what? I'm gonna save this version. So data SIB-mount.png, data SIB-mount.back, and then modify this to show me the angles. So let's say, okay, so this right here is 0 degrees. Okay, this is 0 degrees, right? And this right here, no, actually not degrees, what do we have? Pixels, right? So this is 512. Oh, come on, I need a smaller brush. 512. Okay, so these are gonna be side by side. Then the center of the image, which is at pixel 256, There it is. So the center of the image is 100, no wait, it's 256. And let's also have some intermediate values. So what was that? 256, 128 is here, and then what is that gonna be? 384. Is that 384? I think that's 384. So 384 is gonna be here. Okay, this is sad, but it doesn't matter. File, overwrite. Brilliant. So let's keep that somewhere, and let's do that again to see. Oh, it doesn't. It does. Oh, it shows. Okay, that's fine. Yeah. So basically, what I have is. Oh no. Okay. So it does repeat. It does repeat a few times around the horizon. So what the fuck am I doing here? Okay, so cam theta, which is essentially a value from 0 to 360 and repeated multiple times, is mapped to this, which is divide by 360, so that becomes 0 to 1, multiplied by 512, so that becomes 0 to 512. Alright? Alright. And then we take the modulo with 512, so that basically becomes potentially minus 512 to 512. And if we add 512 to that, so that becomes basically 0 to 1024, which then gets chopped back down to 0 to 256 to 512 when we convert that to an integer. What does that mean? What am I talking about? I don't know. Thinking out loud doesn't really help me. It makes these things more difficult. Alright, so basically how does the horizontal field of view affect this? Wait, and actually, what is it that am I seeing as wrong here? What is it that I'm seeing as wrong? The fact that this rotation doesn't match the rotation of the world. Oh, actually, this depends on the aspect ratio of the image. So basically, it actually my initial assertion that this x value is calculated incorrectly is not right. The problem here is not the starting point, possibly, or is it? Yeah, actually, the problem is both the starting point and the ending point. So I don't need just an x value. That's right. It's so okay. So it's I was thinking correctly initially. It's not just the x value that I need to calculate. It's I need to calculate the starting x position for the first column of pixels and the end x position for the last column of pixels, and then I need to figure out what kind of increment I need, which is not going to be, yeah, okay, so what kind of increment I need so that for every pixel I move the correct amount through the source image in order to make it sync up with the rotation of the rest of the scene. Okay. Okay. Right, okay, so that clears things up. Okay, so I need a starting x position, so x0, or let's call it, I don't know, x start and x end, all right? Now, though, the difference, because if I need to calculate increments, okay, so the thing is, I will need to calculate increments in coordinate space, and then I can't just increment the source pointer by 1 every time. I need to calculate the source pointer based on the current x value. Okay, so I need both x start and x end, and then obviously, in order to have increments that are less than 1 pixel wide, because that's something that is going to be necessary, I will need to use fixed point arithmetic for these values. I can't use just straight up integers. Well, in this case, it doesn't really make any difference, but I want to make it explicit and have all the fixed point values as int 32t instead of just int, to make it explicit that they are 32-bit integers. And I'm going to, let's say, I could use 16 fixed point, 16 bits for the integer part and 16 bits for the decimal part. But I think that's probably going to be a bit of an overkill in this case. Probably best use something like 24 by 8 fixed point. Okay, so what changes now? So let's say that this is the starting. Actually, you know what? I'm gonna make a mapping function, or should I make it a macro? Maybe I can make it a macro. Let's make a mapping macro. Okay, let's call this. What should we call this? Angle to x, angle to pixel. Angle to column. Let's start with angle to column and go from there. Right, so we have a macro that takes a theta value, which is a floating point number, and converts it to a pixel position in fixed point. So what this macro needs to do is basically something like this, all right? But obviously this is going to be theta, and it has to be in a parenthesis because I may pass something weird there. Okay, so after we take theta and convert it to this range, the next thing is going to be to shift. Okay, so before we actually convert it to an integer, after the fmod operation basically, so let's find the other bracket. After the fmod operation, we have the plus 512 there. Do I need to put this after the 512? Yeah, actually in here, after all this shit, I need to multiply the whole thing by 200. Actually, that's a silly way of doing it. That's a really silly way of doing it. So I can control the range here. So it doesn't have to be 512. I can make it something else. Let's not make it extremely stupid. So instead of 512, what's 512 multiplied by 256? 512 shifted by 8 is this thing. What the fuck is this? Yeah, okay, sure, makes sense. Alright, so instead of 512, I'm going to multiply by this number. Alright, so that basically gives me a range of 0 to 512 if I was thinking in fixed point terms, in 24 by 8 fixed point terms. So basically everything else becomes this number. All right. I don't have to do any more operations. And obviously this needs to change now. So that's yeah, okay. So basically -1 wait, no, what? That's what I meant. Right, so this is the mask now that I need to use. Okay. And I can then do something like xstart equals angle to call cam theta. Alright, that makes sense. That was exactly what we had before, but I can do then xn equals angle to call cam theta plus the horizontal field of view of the camera, because cam theta at this point is just an angle, right? So I can add whatever the fuck the field of view is. Let me define that. Instead of having multiple places in the code where I have this 50 magic number, let's call that VFOV. Alright? So define VFOV 50 and then define HFOV VFOV times 1 point whatever the fuck. Actually, you know what? No, it doesn't matter. 1.333333. So I can just return here and add HFOV to that, and this actually gives me the ending, the end column. Or does it? It doesn't, because I don't. I need to not clamp this. Wait, what? Yeah, the x-end needs to be calculated before clamping in the range that I am clamping, if that makes any sense. Because I need those values to be arbitrarily large, so I can then calculate the increment and then clamp x start to the correct range before I use it as a pixel offset. Why am I complicating this so much? This doesn't need to be so complicated. So if I skip the F mode, I just do the mapping to the range that I want without actually constraining it to the target range. I know this doesn't make any fucking sense at all, but it's something I can reason about. So if I skip the F mode, I'm doing the remapping here just for the range's sake. Then, do I even need this function? Yes, I do. I do need this function because there are lots of magic numbers here. But do I need the 512 multiplication? And can I deal with integers at this point, or should I do all this calculation in floating point and get it over with? You know what? Angle to call. Yes, so anyway, let's rethink this. Okay, so x start equals to c round 64 of cam theta, and obviously this needs to be in fixed point. So let's say cam theta times 256. All right. Let's simplify things. So x start is cam theta times 256. Brilliant. Now then, x end equals c round 64 cam theta plus h fold times 256. All right. So now I have the two fixed point values corresponding to these two angles. Just to gain a bit more range, because I would actually want to multiply that later, and I can't do it later because I'm cropping all the decimal points here. I am actually going to go to 16 by 16 fixed point. It makes sense. So 65556 is, I'm sorry. All right. So now that I have those two values, I can calculate an increment. So the increment is going to be the range of values between x end and x start divided by the number of pixels horizontally. So dx equals to x end minus x start. That's still correctly in the 16 by 16 floating fixed point range format. And what we need to do is divide that by FP width, but this is not a correct operation because FP width, or is it? Wait a second. FP width is an integer value. Wait. So if we wanted to divide, let's say by 2, that would be fine. Yeah, no, that's right. That's actually correct. I would have to shift the operands first if I wanted to divide a fixed point value by another fixed point value. But since I'm dividing by an integer, it doesn't matter. The result still stays in 16 by 16 fixed point. That's correct. Do I have enough range to do this operation? I do. Because there are the x end minus x start thing is in the thousands range, in a multiple thousands range, yeah, and divided by, I don't know, something like 320. That's fine. We can do that operation. So that's how much we need to advance for each pixel, unless I'm really mistaken somewhere. And now what we need to do is actually get the x value, actually, yeah, okay, so make the x value being equal to x start. So x equals x start. All right, that's obvious. And then we need to convert that value to to an integer offset in order to use it. Yeah, and now this is where we need to actually constrain this value to the, and it's not going to be an arbitrary range like I was doing before. 512. Actually, it wasn't arbitrary. The range was correct, but it was correct only because that's the number of pixels in the image. This is going to have to be constrained in the range 0 to whatever the number of pixels in the image are, which is actually 512. If that makes sense. So, okay, so the thing is, I have to convert this by multiplying it first by 512, and you know what, I'm gonna hardcode this to give the compiler the opportunity to optimize it with a shift. Or maybe I can do that myself. You know what? Fuck it, I can do it myself. I don't need you. I don't need the compiler. I can do that myself. So x shifted by 9. That's a multiplication by 512. And then, wait, what am I talking about? And then I need, right, so this is not useful. I want to basically shift right by 16 to convert it to an integer, but I want to shift left by 9 to convert it to a 0 of 0 to 512 first. So the difference is, you know what, I'm gonna do this, 16 minus, what was the other thing, 9? Yeah, 7, okay. So I'm going to shift by 7, which is the equivalent shift for the whole operation. Alright, so now x is a value between 0 and 256. You know what? No, I need to keep x in fixed point. Yeah, I do. Alright, so that's where I'm starting with copying pixels from the image from. And then the increment operation. Okay, so dptr++ is still correct, but now what I need to do is, alright, so I need to do x plus dx. Okay, so that's how we move to the next column. And then I need to calculate SPTR again by doing the following. Mount text pixels. So in some sense it doesn't really make any, yeah, never mind. So mount text pixels plus basically the same thing again, but yeah, the same thing, but I need to forgot to constrain it. I need to constrain that. Alright, wait. So this can be a negative value or it can be an arbitrarily large value. What I'm going to do is after the shift, alright, after the shift, do I need the modulo operation in this case, or can I use an AND? You know what, fuck it, let's try it. So if I do something like what I did before, 1ff masked by that, alright, and do the same thing here as well. So in some sense I don't need to do that twice. I can just never mind, x7 whatever. So if I do that, I don't have to do any of this. Let me also add a comment. The SPTR calculations assume mount text width is 512, and you know what, I don't have to do that as a comment. I can add an assert. You know what, not here, let's put that during loading. There you go. Assert mount text.width equals 512, because otherwise, you know what, if I change the image later on, this is gonna break and I'm gonna remember to change all these calculations, and it's an easy thing to do. Okay. Where was I? Where was I? SPTR. Yeah, the thing is, I don't need to calculate this twice. I can do that at the top of the loop, and that's absolutely fine. Alright? And then it just gets incremented, and I'm going to use the new value at the top of the loop. So, but still, do I need to? No, wait. That constrains it. But I do think that we're going to encounter some discontinuities when moving to the negative range. We'll see. We'll see about that. That's easily remedied. But let's try the simple case first. Did I forget anything? You know what? And since I'm actually doing this assumption here, there's absolutely no need for the compiler to do a multiplication here. I can just again do that. Alright? What did I forget? Undefined reference to assert. Obviously, yes, undefined reference to assert, because I have to include assert.h. Ooh, that didn't pan out. Or okay. Yeah, so that doesn't work at all. So that's fucked. Did I forget to convert something? What did I do? dx equals xend minus xstart over fb width. Wait, so why doesn't the initial position first of all change ever? That can only be because x actually ends up being 0 after all the shifts and masks. Why? Why though? Why does it always end up being 0? So x okay, so I'm shifting by 7. But I do have enough range to do that. Right? Why is it 0? Let's print x, see what the fuck is going on. What is it? What is it? Should I print the fixed point value? You know what? Print it in 2 parts. So I'll print d point d. So x shift 16 and x mod, well, not modulo, whatever, ff. Alright. So everything is 0, but when I move it, yeah, no, it's not 0 actually, it moves. And it seems reasonable. Wait, so let's say if this is 0, right, so this is 0, okay, so if I move 90 degrees towards there, it goes to, I don't know, is that 90 degrees? No, it's not, you know what, doesn't matter, I don't think that's a problem. Okay, so the problem though is that even though I have different x values as I'm moving the camera, the image doesn't change, and obviously the increment is way too fast as well, because it repeats the image lots of times across the frame buffer.
So what am I doing wrong here? Mount X pixels plus, so I'm doing X shift 7 because I have to do X shift 16 to take it to a range of, is it the range of 0 to 1? Wait, what is the range? Wait. So these are angles, right? So X start and X end are actually angles in fixed point format. Okay, so dx then is X end times X start over FB width. Okay, so dx is going to be the difference of these two angles over the FB width. So it's actually an increment in angles. So how many degrees we have to increment to move from one side of the frame buffer to the other. Okay? So let's keep that in mind. This is an angle. This is an angle. And it makes sense because as we're moving, it's approximately it approximately matches the angle. Maybe it matches completely. I don't know. Let me see. So this is 0, right? This is going to make it easier to see. So this is 0, and if I move to make us perpendicular to that, yeah, that's 90 degrees. See, that's a 90 basically. Yeah, whatever. That's 90. And this is going to be 120. And this is going to be 270, that's fine. All right, and then keeps incrementing, obviously. So X is an angle at this point. So X is an angle at this point. Does that make any difference at all? That means, first of all, that this offset wait, what am I talking about? So X is an angle, and dx is the change, the angle increment between columns of the screen. Wait, what is dx? Dx. Let's print dx. See what the value of dx is. Obviously, this is not going to change if I move the view. It's 0.13. Is that reasonable? Is that reasonable? Because if we have okay, so if we have something like, how many degrees is it? 50. 50 times 1 point, yeah, okay, so 50 times 1.3333, whatever. This is the horizontal field of view, all right? So if we divide the horizontal field of view by 320 pixels, what do we get? Something different than that. Wait a second, what? Why am I even bothering? Wait. Okay, so I need the starting offset, but the starting offset and the ending offset does not affect the increment. The increment is only a function of the horizontal field of view The increment is a function of the horizontal field of view and the number of pixels. Am I correct in that? Well, if we're still talking about an increment of angles, then definitely. But what I actually want is an increment of pixels. Okay, so what I actually want is how many pixels do I need to increment by in terms of the source image when I'm moving 1 pixel away on the frame buffer, right? That's what I need. So I have the angle, but I do need the calculation that converts between the angle and pixels on the image, pixel coordinates. So I do need that 512/360 that I had previously. I do need that in x start, x end, dx and all that. Okay, so I do need to convert it to fixed point numbers, but I also need to convert it to pixel coordinates. Does it make sense to just divide by 360 at this point? I think it does. 360, no, wait. So if I divide by 360, alright, so basically that becomes a value between 0 and 1, and then multiply by 65,536. That gives me a fixed point representation of that 0 to 1 thing. But I also want to multiply by 512. So basically, okay, so if I go back to the 24:8 fixed point format that I had in mind previously, that means multiplying this by 256. If on top of that I also multiply by 512 and divide by 360, I'm going to have a 24:8 fixed point number that represents pixels now in the destination image, I think. So let's do it the dumb way. So something like times 256, that's for the that's for the fixed point conversion. All right, so times 256 by the fixed point conversion, let's group them together, times 512 for the pixel conversion. And you know what, I'll keep those separate just so I can see which values I will need to change if I ever want to change the I don't know, the image dimensions or whatever. So 24.8 fixed point, 512 width. Alright, so let's keep that in mind. And that divided by 360, which are the degrees. Okay, so that should give me a fixed point value that corresponds to pixels. Let's do the same for x end. So 256 times 512 over 360. Okay, so now dx is x end minus x start over fb width. That's still the same, but now dx is actually in pixel coordinates, which is what we need. X equals x start, sure. Let's drop this. And then we're gonna need to change this operation here. So instead of shifting by 7, now we need to actually shift by I don't know how much is it, by 8 to convert back to integers. Wait, is that it? Shift by 8? So I'm missing something. Wait. I had the 512. Okay, so x, as I said, is a pixel value in 24.8. So we don't care about the 512 part. We did that already. So I just need to shift by 8 and then mask. And the mask should be exactly the same because I have 512 pixels. Does that make sense? I have no fucking clue. So let's try this. And then, is that correct? That is correct. Wait, is that even correct? J shift 9. Sure, yeah, it's J times the width, which is 512. Alright. Oh, that's nice. Okay. That's fucking nice. That's exactly, yeah, and you can see that now it's correct. The points of the mountains match up exactly to where the underlying grid ends up after the rotation. Beautiful. That's exactly what we need. How many times does this repeat though now? So this is 0. Wait, let's start. Okay, so that corner is close to 0. So 1 corner, 2 corners, 3 corners. Okay, yeah, that makes sense. Actually, now this mapping that I created maps the image exactly once around the view. That's how it works mathematically. But I don't want that. Does it make sense that I don't want that? Can I repeat that and still maintain the one-to-one correspondence between rotations? I think so. It shouldn't matter, should it? Wait, let's give it a try. Actually, before I do that, let me see if I can find the discontinuity I would expect to find. So we have this part of the image, right? So if we move that way, as opposed to moving that way, does it make any difference at all? It does not. Beautiful. I would expect a discontinuity, but there isn't one. Okay, so now, can I make the texture repeat a couple of times and still maintain the correct rotation? And how would I go about doing that? So I have this dx, right? This dx tells me how much do I have to step in the texture space for each pixel on screen. If I double that, what will happen? Probably it's gonna get desynced, right? So if I double the X, what do I get? Yeah, obviously now the mountains move with half the rotation, half the rate of rotation of the rest of the scene. Why though? This is because of the mapping I'm doing, but maybe I can tweak that mapping. So it's not that I have to double it here. Somehow, I'm sure I can make that work. I'm sure I can make that work. Am I thinking about this in the correct terms? What would happen? Wait, is it sufficient that instead of dividing by 360 here, instead I divide by 180? Is that the missing calculation to make this work the way I want it? Yes, that was it. Exactly. So now the background rotates in sync with the terrain, but also I have it repeating twice around the whole the whole range of rotations. So does it look good like this, or should I increase that more? Should I make it something like 4 times? A 4 times tiling. No, I think that's a bit too much. Is it too much? You know what? It doesn't matter at this point. I mean, I can tweak that later on, and I can make the image, I don't know, more. I can change the aspect ratio of the image to make this better. I think I will keep it like this because I'm gaining a lot of horizontal resolution, and will make it. I mean, it's gonna look better if I have more horizontal resolution. Right. So this is fine. I will keep it like that. Let me also revert the texture. Data mount. No, what was that? Side mount. Dot old read back. Whatever the fuck that was. Data side mount PNG. Alright. Okay, so that's the correct texture. Now, since we have that down correctly, and the horizontal rotation works fine, I need to direct my attention to the vertical rotation. So what do I need to do to make this rotate vertically as well? I need to position the mountain image vertically according to the rotation. Okay, so that's a bit trickier though, because ideally what I need to do, what do I need to do? No, wait, I have the vertical angle, right? I have the vertical angle. The vertical angle of the camera tells me, essentially tells me, okay, which part of the sphere I'm looking at. So if I was looking at the top, that angle would be 0, I think. Or no. No. Okay, so if I was looking at the top, that angle would be 90. If I was looking at the bottom, or whatever, the nadir, that value would be minus 90. And 0 corresponds to the horizon. So, how do I offset this image
so that it looks naturally to follow the camera angle. You know what, if I'm looking at the bottom, I'm not even gonna see this horizon at all. There is a very limited range of angles where this mountain range ends up on screen. Is there a correct way to calculate this range of values, or should I fudge it? If I fudge it, it's not going to work right, obviously. It's going to be out of sync like the previous attempt. Okay, obviously the vertical field of view plays a part in this. Alright? The vertical field of view plays a part. Yeah, and the idea is that there is a range of angles above the horizon where this image should start and end. Okay? So basically, if the bottom of the image is at 0 degrees, then I need to define how tall these mountains are, which is arbitrary. So I need to define how tall they are in terms of angles. So how large a part of the hemisphere do they cover? That's the interesting bit. That's the point I need to consider. So if I define that angle, then I can calculate, okay, yes, this makes sense. So I can calculate at which angle is the bottom scan line of the screen relative to the view, and at which angle is the top part of the screen, the top scan line, and then that will essentially allow me to position the image so that angle 0 corresponds to the bottom of the image always. So I can calculate an offset based on the angles of the top of the screen and the bottom of the screen. Yes, alright.
So that makes sense.
I think that makes sense.
So the calculation will be similar to what I did for X start and End start, but it's going to involve the Y coordinates. So let's start there, in 32. So I have a Y coordinate, maybe I'm going to need this, probably I'm going to need this. I also need Y start, Y end, and dy. Let's say it's identical to the previous calculation. It probably is. So the only difference is going to be that, so now that Y start is going to be C round 64 of cam phi. Now though, cam phi is a value from minus 90 degrees to 90 degrees. Alright? Does that make any difference? I don't think it does. So cam phi, let's call it again 256 times 5, it's not 512 though. The vertical resolution, what's the vertical resolution? Identify, and you realize that I could just use mount text width and height in this case. I'm not doing it for performance reasons, because the compiler can optimize all this to a single, instead of calculating all that, it can optimize it to a constant, basically. That's the idea. That's why I'm even bothering to look up what the actual image is, instead of just using the information I get from the loader. So identify data mount text, no, it's not mount text, what is it called? Side something. Side mounted PNG. Alright, so it's 128 vertically. So this becomes 128, and I'm also gonna add an assertion for the height, just in case. So assert mountx.height is equals to 128. All right. Where were I? All right. So wait, does this 90 make sense? What was the 90? Okay, no, the 90 in this case was the part of the the slice of angles covered by a single run of pixels of the image. So in my case, in the Y case, let's say, this is going to have to be something like, wait, do I even, I don't want to remap the image vertically. I don't necessarily want to step on sub-pixel coordinates or multiple pixels per step. I don't want to remap the image. I want to use the image as is, but simply offset it. So I don't necessarily, do I need the dy? Wait a second. Do I need the dy? Or do I simply need a single angle? I think I do need a single angle. Alright, so let's do it differently. Let's say I just have a y value, whatever. Okay, so I still need to calculate in the same way, but I think I only need that one value. And alright, so that's cam phi times 256 times 128 over, but is that how much of the hemisphere is covered by my image, or is it, what is the nature of that? I think that should be 180, because that's the range of values of cam phi. I think that is correct. I'm not absolutely sure, but I think that is correct. So in this case, right, so now I have a y value that okay, so I'm dividing by 120, right? So that makes it, no wait, that's not correct, because cam phi is minus 90 to 90. So I don't want a value, wait, what do I want? Do I want a value from, why is this confusing me? So I'm, we have the, okay, we need to convert that to pixels, alright? Because that's going to be our offset. We need to convert that to pixels. But is it image pixels or is it frame buffer pixels that we need? And does it... because the offset is going to be in frame buffer pixels. Okay, that's interesting. So I need to calculate an offset. I need to actually make a couple of trial and error tests instead of trying to figure it out from the top of my head. But I do believe, now that I come to think about it, I do believe that I need to convert this y value to frame buffer relative offsets. If my thinking about this is correct, which I'm not entirely sure at this point, then I probably need to multiply this by 240, which is the vertical frame buffer resolution. And you know, I can even use FB height here. Let's try that. FB height. So multiply that by FB height, and we have a value. Okay, so first of all, divide by 180, right? Divide by 180, in this case, means a value from minus 0.5 to 0.5. Is that what we want? Probably not. Probably we want a value from minus 1 to plus 1. Yes, no, wait. Actually, I don't know. A value from minus 1 to plus 1. And then multiply that by the frame buffer height. That doesn't make much sense though, because that would map the range of rotation. Yeah, you know what that would do? It would actually make the image be at the bottom of the screen when I'm looking down, and just off the top of the screen, or maybe the other way around, when I'm looking up. And that's not what we want to do. That's not at all what we want to do. What we want to do is for the image to follow the horizon. But what is the horizon in this case? Where does the horizon end up? At which pixel coordinate? Wait, do we have to do a projection for this? Or is trigonometry enough? Wait, I need to think about this. Actually, I need to make a diagram to really understand the issue. And you know what? I'll try to make the diagram on GIMP so that I can share my thoughts. But if this becomes too awkward, I'll just revert to pen and paper and you'll have to take my word. Okay, so whatever, it doesn't matter. Right, so let's say this is the center of rotation, all right? And let's say for 0 degrees, okay, this is the plane, the ground plane, okay? And then we have a hemisphere of angles. So that's minus 90 and that's 90. Alright. This is 0 degrees. What I have to figure out is a mapping between pixel coordinates. Okay, so look. The range of pixels depends on the field of view. Okay, so that's our camera field of view, the vertical field of view. What we need to find out is, depending on the angle of this, depending on the angle of the center line of the camera, which in this diagram corresponds to 0 degrees, but it could be something else. You know what? Let's make a better diagram. So let's make a better diagram. Alright, so this is the plane, and I'll use red for the camera. Okay? Alright, so if this is the center of rotation, and let's say that the camera is pointing so that the bottom of the screen ends up on the horizon. That's one corner case. Okay? So that's the camera field of view. So it starts from 0 degrees basically and ends up wherever. The angle of rotation of the camera, which corresponds to cam theta, is this angle. That's theta. No, that's not theta, sorry. That's phi in our code. Whatever, that's phi. Alright? That's phi. Okay, so the point now is that I need to know this actually is probably extremely easy, and I don't know why I'm not thinking about this correctly, but I need to know the angle. Do I need to know an angle, or do I need to know pixel coordinates at this point? Maybe I just need an angle to begin with. So I need the angle of the ground plane relative. That's extremely easy. Alright, so the angle of the ground plane relative to the angle of the camera is just a subtraction. That's easy to do. In this case, in this example, it corresponds, basically the angle of the ground plane is minus half the field of view. Alright? Alright. So if I know the angle of the ground plane relative to the angle of the camera, that gives me where the mountain range should start relative to the camera view in degrees. Is that extremely simple? Am I completely dumb? Okay, so the angle of the camera, the angle of the ground plane in this example is v/4 over 2 minus v/4 over 2. Right? Does that give me an offset? It does, because I can interpolate between the extrema of the field of view to figure out a pixel offset. Sure, that's obvious. All right, let me think in terms of code. Okay, so if I can calculate the angle of the ground plane, which I can, what is the angle of the ground plane? The angle of the ground plane is cam phi minus, wait, what is the angle of the ground plane? Okay, let's write some pseudocode. G angle equals cam phi. We need the angle of the ground plane relative to the angle. Wait, that's just minus cam phi. Wait, what? Minus cam phi.
Yeah, because if the camera moves upwards, so cam phi becomes positive, the ground, yeah, obviously, okay, so obviously the ground, okay, never mind.
So now, what I need to actually calculate is the angle relative to the ground plane of the bottom of the field of view, right?
So what is that? That's the angle of the last scan line is minus, okay, so it's cam theta minus v4 over 2, as I said previously, minus cam, wait, it's, yeah, it's cam theta minus v4 over 2, that's obvious.
Alright, so let me write a bit of pseudocode here. So the bottom angle is cam phi, minus v4 over 2. Okay, that's obvious. And the top angle is again by symmetry cam phi plus v4 over 2. That's also obvious. So it stands to reason that the angle so the thing is that the mountain range should start at angle 0 and extend upwards. Okay? So what do I need? The pixel offset is going to be C offs. Pixel offset is going to be so it needs to move down when the camera moves up. So I need to convert. Okay, so I need to convert these angles to offsets. Yes, that is correct. Okay, so I need the top y offs, which is going to be angle to screen row cam whatever top angle, all right, and bottom y offs is going to be angle to screen row of the bottom angle, and then we can calculate the offset of the mountain range in terms of those two offsets. So if for instance, if No, basically just... Do I need the top and the bottom offset? Yeah, so the first one gives me the offset in screen coordinates of the top. I don't need the offset of the top. I need the offset of the center in screen coordinates, because that's what the offset of the image is going to be. And then I just need to clip that. It's extremely simple. Okay, so in that case, alright, so basically what I need to do is y equals to C round 64 cam phi times 256 times 240 over you know what, let's try this. Let's see what it does. Okay, so now the idea is that we don't start copying pixels from the top of the source image. I'm really overcomplicating this, and there is no need to overcomplicate it. So I have a y coordinate that I want to be the offset. You know what, before anything else, yeah, it's a destination offset, obviously. Yes. Alright, so so this stays exactly like that, but we might need to start, we might need a delayed start. Let's make it extremely simple at first and optimize it later. So if, alright, so if j plus what's that, y shift 8, and we don't need a modulo operation. So if j plus that plus the offset, if j plus the offset. And you know what? I probably don't need that to be in fixed point coordinates at this point, in fixed point format. I can probably just keep the integer part and be done with it. Yeah, I don't need the y coordinate to be fixed point at all. So let's say we don't need that part. Alright, so that simplifies this slightly to j plus y. If j plus y is greater than 0, do this, alright, and else if j plus, come on, if j plus y becomes greater than or equal to fp height, then break. And then we need to increment y, no wait, we increment j, no, y, we don't need to increment y. Alright, so let's see what this does. Okay, so this doesn't work at all. That's interesting. Yeah, obviously yeah, SPTR is always pointing to the, I mean DPTR always starts at the top of the screen, which is incorrect. Yeah, so I need to actually offset DPTR by adding, what do I need to add? Y times FP width. Is that going to crash? Ooh, it does something, it does something. It does something. It's obviously inverted from what I need, and I'm afraid to move it past the screen bounds because it's probably gonna crash. Let's see. It doesn't crash. Oh, that's nice. That's nice. Ooh, what happened? I think now it crashed. All right. So first of all, the direction is inverted. So let's make that minus cam phi. So at least now it moves towards the correct direction. It doesn't match the motion of the... Well, actually, one problem is that it starts from the top of the screen, so that's clearly incorrect. What I need to do is start it... So if the angle is 0, this needs to start with the bottom of this image at the horizon, and obviously, okay, so obviously the horizon depends on how high I am from the horizon, but since I don't think I'm gonna move that much, I can simply fudge it and consider the starting point to be the center of the screen. Is that making sense what I'm... yeah, you know what, let's try it. Let's say that y should start from FB height over 2. Oh, this is clearly wrong. Okay, so FB height over 2 minus the height of the image itself. So that's what it was, 128, I think. So no, that's clearly incorrect. What am I doing wrong? FB height over 2. Actually, you know what? I think I need a brighter image so that I can see the bounds. Let's do that same trick again. So let's copy data zip mounted PNG to data zip mounted back, and let's modify this image, not this one, closer. Let's modify this image again to add a bit of context. And actually, you know what? There is a problem with this image. There is so much wasted space vertically. I actually don't need the mountains to start so high from the bottom of the image. So the best thing I can do is probably scale the image, or maybe just cut it in half. Can I cut it in half? How much is gonna be if I cut? Ooh, that's rounded corners. I don't want rounded corners. Alright, so if I use something like 64 pixels height, oops, 64 pixels, do that. Oh yeah, that's absolutely fine. So I'm going to change the, come on, oh come on. How do I move this? Do I need to, no, not that. I used to be able to move that. What happened? Replace the current selection, add the current selection, intersect, what? Okay, let's do that again. So I have a box of size 64 vertically, and I can move it. Okay, so something like this should do the trick. Image crop file, and also just for this experiment I want to mark the bottom of the image so that I can see what is going on with the offset. So let's choose a smaller brush and run a couple of lines. Actually, you know what, run a complete line at the bottom of the image. Okay, file, override. And obviously now I need to change this assertion to 64, and also, by the way, this doesn't have to be a power of 2. This is just okay, so do I have anything else that needs to change? No, I think not. Oh yeah, 128 here. So 64. Let's see. Okay, so that sort of makes sense. Is the angle 0 at this point? Wait, what's the initial angle? No, the initial angle is 10. Let's start with an angle of 0 just so we can see where this ends up. And I'm higher than the horizon. I'm a bit higher than the horizon. I mean, this is reasonable. And the motion doesn't follow exactly, but the offset is reasonable. So what do I have to do to make this follow the horizon exactly? Because you know what, if you extend this line, the image should go much further down than it does and much further up than it does. So the amplitude of the offset is wrong, and I can probably make it work if I fudge these numbers a bit. But is there something I can do to make it consistent even if I change things? Alright, so what am I doing now? I'm dividing my 90. Is it the case that it's just half as much as I need? Do I need the whole range there? No. So I'm actually I am actually gonna be fudging some numbers because I don't wanna calculate this. I think that's reasonable. You know what? I think I'm gonna leave it like that for now. I don't care for this to be extremely precisely correct, I think. And you know what? If it turns out to be a problem, I can fix it later. Alright, so... no, sorry. So I need to remove that red line. Save and exit. Alright, so this is fine. And now what I need to do is actually use transparency. I have a compiled sprite system. Which would handle this very efficiently. But I'm not sure if I can use this for a white background like the mountain range. Can I? Okay, let's do the simple approach first, just to get this out of the way. So the simple operation is, okay, we're copying a pixel. We're copying this source pixel to the destination frame buffer. Ideally, what we need to do is grab the value of that pixel, put it in a variable. So call equals to sptr j shift9. Alright. And then if call not equals to whatever the green value is, so basically what is it going to be? It's the color format is 16 bits 565, so it's going to be 5. What's left? Okay, so we have 3 bits at the top of the first byte, so that's going to be E. What? 3 bits at the top of the first byte, yeah, E0. And then another 3 bits at the bottom of the second byte. So that's obviously 3. No, sorry, that's obviously 7. So if the color is not green, do this. That's the operation. And obviously we can't see it because the background is red. The background is black. But if the background was another color, so let's say, where is it? Clear color to something like, are these integers? I don't remember. SRC, 3DGFX, clear color. Okay, they are integer values. So if the color is something like, and I'm going to replace this with a gradient at some point, but let's just say, for argument's sake, that the backdrop is something like 125, 70, 136. All right, that's probably going to clash with the grid, but never mind. Yeah, let's make it slightly bluer. Let's do something like this. So 85, 70 again, and 130. Really? All right. Okay. Right. So, okay. Obviously, I need to take into account that anything below the horizon is going to have to be black, and anything above the horizon is going to have to be some sort of gradient. But anyway, the point is that this works. This is inefficient though, but I don't think I'm going to fix it today. The problem is, where are we? The problem is that inside the inner loop where we're copying pixels from the source image, we have to every time do this comparison and branch. And this is inefficient for many reasons, not the least of all being that branches may be mispredicted and pipeline stalls occur. And also it's a few more instructions to do when they don't necessarily have to be there. And the idea, in order to fix this, well, one way to fix this is to pre-compile. Yeah, but we can't do that though. We can't do that because we're actually stretching the image based on the horizontal value. If there was a fixed image that a fixed size image that I'm just bleeding to the screen, I have a system where I can compile this image into a series of assembly instructions that only write the pixels that need to be written on the screen without any conditions at all. But I can't do this in this case. What I can do probably is some sort of run length encoding. I can encode the image as runs of pixels which tell me where there are non-transparent spans in the image, and then, but you know what, that doesn't help me either because of this this variable offset. I'm sorry, basically because I'm not necessarily moving one pixel at a time through the image. So I have to think about this. Probably this is the best thing we can do. I don't know. But for now this works. The only other thing I want to do today is make sure everything below the horizon is black. So how do I do that? So everything below the horizon needs to be black. Actually, you know what? I think I need to handle this in here. I can't do that. I can't do that with a frame buffer clear easily. So I have a pointer to the frame buffer with an offset . Yeah, so dptr okay, and this y offset is actually pointing to where the start of the image is. Alright, so that's actually pretty easy. What I need to do is find where I stopped drawing the image. So basically, am I incrementing something here? No, it's just j plus y. Okay, and j goes from 0 to what is it, 64. Let's fix that as well. Let's make that 64. Alright, so the point is that if y plus 64 ends up being less than 240, which is the size of the screen, then I need to set dptr equals fb pixels plus y plus 64. Well, basically y plus 64, alright. And this times the width of the screen, and then do a memset dptr 0. Now, how many bytes do I have to set? It's gonna have to be, actually, you know what, let's do it in a way that simplifies it slightly. So y plus equals 64 brings us to the bottom of the image. So if y is less than 240, then the pointer points to fb pixels plus y times fb width, and we memset for fb height, which we can actually replace here, fb height. Let's also replace it here. It doesn't make a difference. Wait, what? Really? Okay. In any case, it should be fb height minus y times fb width, and that's actually the number of pixels times 2, because every pixel is 2 bytes. So we fill that with 0. I might be off by 1, but I do not care because I have a guard band around the frame buffer. And this makes sure that below the mountains we have a black pixels only. So it's like as if the mountains continue and are part of the terrain below. Below this grid, let's say. And if I move it too high, it crashes, but I'm gonna fix that another day. Actually, let me see where does it crash. It doesn't crash actually, it goes into an infinite loop. And where is that infinite loop? Draw bleed frame. What? Bleed frame? Is it memory corruption? It doesn't make sense that it's stuck in bleed frame. Include swap buffers. Okay, it's some sort of memory corruption, obviously. You know what? Fuck it. Let's try something. What? Okay, something is broken in this. Okay, yeah, okay, alright. So the problem is that this is a 32-bit binary, and I'm missing something. Okay, you need the corresponding 32 debug info package like libc. let's try to install that. You know what? Not here. The reason why I'm building this project as a 32-bit program, even for the Linux version, is that maybe I have some bits of assembly which are part of the effects as optimizations or whatever, and I want to be able to use those same pieces of code in both the DOS version and the Linux version without modifications. So I'm building the whole project as a 32-bit application. This is taking way too much time. Oh, it's done. Alright, let's try this again. No, nothing. Oh, actually, wait, does it continue working? I can see some animation. Can I change? Okay, so it didn't actually crash. What is going on? Why does it get stuck like that? Yeah, it continues working. I thought it crashed, but it didn't. I just can't move the screen for some reason. Can I move it in another part? Alright. I don't understand what's going on. This is probably still a bug. This is probably I'm overriding something, and I'm overriding some part of the data in this part of the demo. So if I actually sit down and reason about this, I can figure out what's going on. So I have dptr, which points to fp pixels plus y times fp width. Alright, that's good. And then, okay, for it to override something when the offset becomes large, because this happens when the mountain range moves downwards, and possibly it starts happening when the bottom of the image goes below the screen, right? Right. So at this point, the mouse cursor disappears. I cannot move the anything anymore. So obviously something got fucked. This means that the Y offset becomes larger than FB height. Wait, so Y, if Y becomes larger than FB height, what does it happen in that case? So I have J plus Y larger than FB height.
Probably this condition is wrong.
So, just for fun, if I divide this by 2, does it still happen? It does. Alright, so that's not it. If J plus Y, is that correct? So if J plus Y is larger than 0, this is the only case where we write to the frame buffer, but also oh yes, this is an LC. What am I doing? What the fuck am I doing? Jesus. Jesus. Alright. Ooh. So we fixed this we fixed this bit, but in this case is still fucked. Alright. So if J plus Y greater than 0, in that case, actually, you know what? Let's print that. Let's see how that Y value changes. So this is whatever 56. If I take it upwards, it becomes less and less, and now it becomes negative. And for a while it's fine. By the way, I don't see the top scanline there. For a while it's fine, and then alright, so that's pretty much what I expected. It's a bit more than 64 because I have a bit of a guard band at the top. By the way, that should be greater or equal to 0, which would make that line disappear from the top, right? Yeah, that's right. Okay, okay. So, what's going on? So there is this negative offset. Becomes minus 64, let's say. And J plus minus 64 is greater than 0. Look, obviously it's not gonna crash if this is not executed, okay? Oh, it is. Alright. Is this the problem? Oh, this is probably the problem. Oh, right. Yeah, obvious. Okay, obviously. Sure. Because in this case, yeah, okay. So, look, if y, I forgot about this part of the code, obviously that's the problem. So if y is less than 0, in that case, we just want to clear the whole screen. So nothing else matters, we just do a memset, whatever, dptr, not even dptr, fb pixels 0 fb width times fb height times 2, right? Only if y is a positive offset, only then do we execute this bit. Otherwise, we're just trying to memset to coordinates before the start of the frame buffer. That should fix it. Alright, so this is... well, okay. Not quite. Yeah, close, but not quite. Alright, so this should be... We first need to add 64 and then do the rest. Is that right? Yes, that is correct. Okay, so that is fine. I think that works pretty well. I'm not gonna bother with the rising sun or anything else today. I think I'm gonna leave it for the next session. So thanks for watching, if you did watch all this, and see you another time.